Okay, so hello everyone again, and welcome to the DevRain Transform 2022 conference. It's me, Anton Boyko. I would like to welcome you all. Sorry, it's a bit dark at my place here, and today we will have a bit of experimental format. If you will ask me why we will have an experimental format and why it's so dark here, this is all thanks to our neighbors who are currently trying to invade our country, but we're kicking their asses. Anyway, even though there is a currently war happening in Ukraine, it cannot stop us from basically having this conference. And again, thanks to all of you who joined this workshop. So I will be running this workshop today. This workshop will be, I see that we, like have not really a lot of attendees here. So that basically means that if you want to ask some questions that are more, like related to how everything that we will be talking about today is applicable to your project, is applicable to your organization or something like that, feel free to do that. This is a perfect opportunity for us to have like a more, let's say, personal kind of a conversation. So a few words about myself, if you never met me before. So I drew a lot of things on the internet. And yeah, before that, I was doing a lot of things on offline. I'm mostly well known for my experience in Microsoft Azure. I'm Microsoft Azure MVP for 9 years in a row. And in addition to that, I have how many? Probably like 11 or maybe even 12 years of hands-on experience with Azure. I was doing a lot of things related to the DevOps in general, and that is why Mr. Alex invited me to this conference, to this workshop, to talk a bit about not only what the DevOps mean, but also what the MLOps mean. Because as I was basically stating that in the description of this session, it may look like you can just put an ops at the end of anything like MLOps, FinOps, GitOps, NoOps, whatever ops, and yeah, now you have a new area that you can master. But is it truly true, or MLOps is actually a thing that is a bit different? And if it's a different from a traditional DevOps, then we will probably try to figure out where and how it's different. The most important part of our session today will be how to actually get started. So I do assume that the attendees of this session are at least to some degree familiar with the DevOps basics, with the basics practices like, for example, continuous integration. You know what the pipeline is in general, how to automate the build, for example, of your own application. It may be a .NET application, it may be a JavaScript, Python, I don't know, even PHP application. I don't care. If you have at least a tiny bit of experience with that, then you are basically a perfect attendee for this session. If you don't have an experience with that, that's fine. I still do believe that you will be able to follow. So anyhow, let's actually get started. So for now, as I was saying, the format is a bit experimental. So for now, I will just say a few words about what the DevOps is in general and how it potentially may or may not be different from the MLOps. Look, so the thing here is that if you will basically go outside, if you will walk on the street, and if you will, I don't know, meet 10 random people and ask every one of them what DevOps means to you, you will actually have 10 different answers. And the thing is that to some degree, all of them will be correct. Because let's try to, I don't know, like analyze a few potential answers for that question. So the DevOps for someone may mean that it's all about the automation, which is true. For some other person, it may mean that DevOps is about treating your resources as a code, something like infrastructure as a code, you may heard this term, and so on and so forth. And this is also true. For someone else, DevOps may mean that when we're talking about DevOps, we're talking about a really, really small and tiny deployments. We want as soon as we did even the tiniest improvement to our product, we want to ship it away, which is also true. So all of that is about DevOps. But if we will try to take a look under the hood, so how we usually do DevOps on our projects, because when we're talking about DevOps it's not really, like about the tools, it's not even about the technologies. DevOps, it's about the communication, and DevOps it's more about the culture of the organization. But nonetheless, let's take a look how we usually do DevOps on our projects. So usually when we're starting with the DevOps, we're starting with implementing some simple practices. Maybe we start with the build automation, maybe we start with the test automation, maybe we start with the deployment automation. And to be honest, if we will try to apply the same principles, the same methodology to something that is called the MLOps, then we will see that actually they will work exactly the same. So let's try to compare those two scenarios in more detail. So let's say that we're creating a regular app. I don't know, let's take some simple app like even like to-do list or something like that. So on one hand, we have the to-do list. On the other hand, we have I don't know, like ML model, which I don't know, which was trained to predict, for example, what will happen with the currency exchange rate or something. So when we start, what we do, we write some code. We write some code for our to-do app, and then if we will take a look at our ML model, what we're doing, we write a code for the ML model. Then we check this code in to our source control. So in both cases, this part of collaborating on the code looks exactly the same. The only thing that is a bit different, but actually it's only looks a bit different. The only thing that is a bit different is how we work with the test data, because with the to-do list, we don't truly care. So in most cases, when we create a regular application, we don't truly care about how we manage the test data, especially if we are on the really, really, like early stages of the adoption of the DevOps practices. But when we're talking about creating a machine learning model, then the test data is an essential part of that model. I mean, like we cannot just ignore it, because without the test data, the model is meaningless. It's more or less the same as, that's like in this old joke that we can go to casino and basically bet everything on black or red, depends on your personal preferences. So, but for now, I want to kind of move it aside, and I will get back to this part in a few moments. So we're creating the code. We're basically pushing, checking in this code to the source control, and everything works exactly the same when we're creating a regular app or when we are creating a machine learning model. The next thing is usually the build automation. Okay, so when we're doing the build automation for the regular app, it's a more or less well-known and established process. So what we're doing, we first may restore some dependencies if we're using some package managers. Then we may want to compile our application if it's a compile language, or transpile, or if it's neither of those, then just basically copy all the files and publish them as a package of that application. With the machine learning model, it's exactly the same, but now, so we have our code, we have our data. Now, what we need to do now, we need to train the actual model. The difference here is that probably the biggest build server that I saw in my life for the regular application was about like 8 cores and 32 gigs of RAM. that was the biggest build server for the regular app that one of my clients was using to manage their purchase orders. But when we're talking about the machine learning model, here everything is a bit different because I do believe that in the machine learning world, if we're talking about 8 CPU cores and 32 gigs of RAM, that will be not the biggest, but the smallest server. But look, here the only difference between how we automate the build of the regular app and how we actually automate the build or the training part of a model, the only one difference is actually only in the infrastructure that we're using underneath, because we know that to train the model, we need to use a powerful machine. So, okay, we may use not 8, but let's say 32 cores, or we may have, I don't know, like half of the terabyte of RAM, or maybe we need to have a machine not only with the CPU, but with the GPU. It depends on a lot of things. But the process itself is exactly the same. What we're doing next, when we're creating the regular app, we may want to run some unit tests, some, I don't know, like integration tests, and so on and so forth. When we're creating our model, we also may want to validate our model. We may want to run some tests. The thing here is that usually we treat those tests different, because when we're talking about the, let's say, unit tests for the regular application build automation or integration tests or whatever, for those tests we care only about the actual result. So for example, I care that I have 100 tests and all of them are green, and also I may care that the code coverage should not go less than 95%, for example. But the point here is that all that information I'm able to get from the current run. When we're talking about the validation of the machine learning model, here it's a bit tricky. So it also looks like the test automation, but here the essential part of it is that now the quality is measured not in how many lines of code are covered with the test, or I don't know, like how many tests are green and so on and so forth. Now the quality is measured in a different way. For example, if this model needs to predict something, predict an event, and we have a set of test data and a set of validation data, we want to basically calculate what will be the I forget the English term, what will be the correct or like the success rate of those predictions. So usually the success rate or like the correct prediction rate, which is above 70%, considered as a really good prediction. So if we can make 2 out of 3 predictions correct, then it means that our model is well trained. But the thing here is that when we are building, let's say, the new model, we always try to improve that quality. So we always try to get the higher score here. And the thing here is that if we will only measure the current score, it will be pointless. We need to measure what was the score for the previous run and the run before that, and so on and so forth. So now this is the first significant difference between the regular, let's say, approach to DevOps, to build and test automation, and to MLOps, because with the MLOps we do care a lot about trends. Here, I also want to maybe kind of, take a small detour and talk about the other quality attributes of the potential model, because we all understand that, okay, I was talking about the accuracy of that prediction, which is of course essential, but in addition to that there are a lot of other attributes, and the next one probably that is the second most important, but in some cases it may be even the first more important attribute. So the other quality attribute that is important to measure is the performance. So for example, if I improved my accuracy of predictions by 1%, but now it takes me 10 times longer to predict that, to calculate that prediction, then I still may want to use the old model just because in my scenario it makes more sense. I can sacrifice the accuracy, especially I can make, for example, the small sacrifice of only 1%, but I really, really care about the performance. What it actually means? It means that this the quality part of your model, you need to understand exactly what the quality part of your model will be and what quality attribute you value over another quality attribute. Because sorry, we all know that we cannot achieve everything at the same time. So we cannot create a, a model that will be super accurate and that will perform super fast. We always need to find a balance. This is not really related to the MLOps part, but I saw a lot of projects that failed, especially on that part, on understanding this particular part. Then when you are creating something, you can always improve. I mean, like if I will go to literally everyone and ask them what can be the next thing that you want to improve in your project, that will always be an answer. But the thing here is that you need to understand not what you may improve, you need to understand also when you need to stop improving that. What will be considered as a good enough? Let me give you an example. In terms of the accuracy, you may say that, hey, like 75% accuracy for those predictions is good enough for my case. I don't want to invest any more money in this model. I don't want, okay, it's still like I don't want, but I don't want to overpay and increase this accuracy from 75, let's say 80, because it may take, I don't know, like 1 million of something, let's say 1 million of American dollars to increase that, but the actual business profit from that may not be enough to cover that investment. And the same goes, for example, with performance. You may say that, okay, I want this model to be able to, let's say, return the prediction value in less than 500 milliseconds, or in less than 1 second, or maybe in less than 300 milliseconds, whatever. If it can return the response even faster, that's fine. That's awesome. But if we already reach that threshold, if we already reach that goal, then we can actually stop improving and then we can dedicate our efforts on something else. About dedicating the efforts. This is another interesting topic on how actually you will understand which exact part of the automation you should handle first. Let's say that you already have a project, okay, and let's say that you are already building some models, and then you, I don't know, let's say you build them manually, you test them manually, then you pack and deploy them manually as well, and that takes a lot of time, a lot of resources, and everyone are suffering. And now you ask someone, hey guys, can you recommend what we should do next? I mean, like, we know that we want to invest into the automation, but where we should start? So for that, another part that is similar between the DevOps and between the MLOps, and probably it's not even the DevOps related. I do believe this is in general a really, really good rule of thumb on how you can fast understands which exact area you need to dedicate your efforts. So the thing that I'm talking about called the waste removal exercise, and that waste removal exercise, it came to us, I do believe, from the Toyota. And you may know Toyota as an authors, as the creators of the Kanban system in general. So the waste removal exercise is super simple exercise. So what you are doing, you are, for example, on a whiteboard together with your team, you are drawing like a pipeline. So what is happening from the starting point? And the starting point may be, I don't know, like that someone created some requirements for you or something like that, and then the endpoint. And the endpoint is basically means that you took those requirements, you create all the code, you tested it, you deployed it, validated it, and now the end user can use it in your app, in your system. So the waste removal exercise goes like that. So you draw that pipeline, you specify all the steps. So here we're doing this, here we're doing that, and so on and so forth. And then you mark them and you're saying that, for example, here we are usually spending, I don't know, like 2 days. For this, maybe like to deploy the model, we're usually spending like 3 days. To test the model, we're spending like, I don't know, 10 days, and so on and so forth, because we do have a huge data set and we need to validate that from all the different angles. And also then we need to engage maybe with some experts and we need to ask for their help so they will also validate that the model is working as expected, and so on and so forth. And the idea of that waste removal exercise is that as soon as you will write all those things down on your whiteboard or whatever, you can start thinking, okay, what we can automate here, what approximately it will cost us in terms of efforts, and what the approximate benefit we will get from that. So let's say that if you will automate the deployments of your model, then you will save, I don't know, maybe like 10 man hours, or sorry, 10 man days per month, because now you need to deploy everything manually, and this is a very complicated process, and so on and so forth. That may be the case. Or maybe, as it used to be in one of my projects, when they were creating their application, they uh, they didn't invest upfront in the test automation. So for them, it usually took about 2 weeks to implement a new change on average, and then yet another 6 weeks to test that the change that was implemented is actually working as expected. Nothing was broken from the previous release, and so on and so forth. So for them, it will make more sense to start automation with the testing, with the validation part of it. This is a really important statement, and I really want all of you to understand that. And the reason for that is because in that case, when you are doing that, you understand exactly how to get the quick win. Because if you will, by any mean, decide that, we need to start our implementation of MLOps practices from the beginning to the end. And from the beginning to the end will mean that, for example, we'll need to start that implementation with, I don't know, build automation. It may be that build automation is not your biggest pain point. So that's really crucial before you will start implementing something to go with this exercise. And another extremely important advice for all of you guys is that before you start to implement something, there is another thing that you need to do. So first of all, you need for yourself to define what you will qualify as a success. For example, you started to working on the performance improvement or accuracy improvement. And you're saying, okay, for us, the success will be if we will be able to improve the accuracy of our model by 5% or by 10%. Okay, so this is your goal. But before you start with any implementation steps, you need to measure the baseline. You need to know what your current accuracy, then you go with the implementation, then you measure it again. If you forget to measure your baseline, you may actually, in fact, like you may actually improve your model accuracy even more than by 10%. But at the end of the day, because you didn't know what was the baseline, you will be unable to present that result. And yeah, all the automation initiative may actually go down the drain just because you didn't present the results correctly. Anyway, let's actually get back to our topic. So getting back to our topic about the MLOps and the DevOps, so we established for now that they actually are the same, or they look the same. The only difference that, at least for now, we highlighted is how to when we're talking about the MLOps, it's really, really important to understand not only the current results of your validation, but also to understand the trends. So what was this what was those metrics for the previous versions of the models, and so on and so forth. On that one, I want to actually make another important statement. And another important statement is about how to actually get started. Talking about that, I always remember in the guy, I met him in person. I talked to him a few times. The name of the guy is Donovan Brown. Donovan Brown works in Microsoft, and the reason why I always remember him in this kind of situations is that I'm not sure that this is actually his original quote, but maybe it is. But at least I heard that phrase from him the first time. And the phrase is like that. If you can show me how to do that in a command line, I can show you how to automate that with, and then basically put the name of your favorite automation tool, like Azure DevOps, like GitHub Actions, like, I don't know, Jenkins, whatever. So now we're actually talking a bit on how to actually get started. And again, to get started, the easiest thing to get started is to understand how you can run those things from the command line. So let me just try to open a few things on my end, just to use them as a very, very simple examples. Those examples, I pulled them from the internet. By the way, there are a lot of learning materials on the official Microsoft website, and I would actually probably share them with you even now. So let me do this, and let me start sharing my screen. Desktop, this particular desktop, allow. Okay, so my webcam stopped, and the Teams is basically saying to me that it stopped because I'm sharing my screen. So I'm operating under the assumption that you can see my screen here. So what I'm having here, first of all, you need to remember this link. I believe we can provide this link actually as a part of the description on the website for the current session. But the thing here is that this is the perfect learning challenge for the MLOps from the Microsoft. You will go through 7 challenges because everything cool starts with 0. You will go through 7 challenges, and those 7 challenges, it may took you maybe like a day, maybe like a few days, depends on your experience with the Python, with the machine learning, with the GitHub Actions in general, and so on and so forth. But I really, really recommend that as an extremely good starting point. And we will start with the first part. I will show a few things here with convert a notebook to production code. So what I'm having here, I'm basically having here my Visual Studio Code. And if I will open this guy here, just scroll it a bit. No, I don't want to update my Minikube. So this is, as you can see, the Python node, sorry, not the Python, the Jupyter notebook. So this is the Jupyter notebook. It's a very well-known tool for everyone who is doing the machine learning. And the idea here is that in the Jupyter notebook, it's really, really simple to basically work on your model because you have all of those sections. You can run all of them independently. You always have the results of the previous on the previous section, and so on and so forth. Unfortunately,
Anton,
if I
sorry,
will,
you just
yeah,
shared the Teams screen, not the overall screen.
okay, that's interesting. Let me then try to do that again. That's strange because I was choosing the second screen. Allow. So, okay, can you see my Visual Studio Code now? Let me open the chat. No, same. Okay. Let me try it in another way. Huh. I see my VS Code now.
Yes.
Awesome. That basically means I don't know actually why it happens, but that basically means that for some reason my laptop screen is the screen number 2, while my extended monitor is a screen number 1. I don't know why, but anyway. So, nonetheless, let me then just show you this part again. This URL, as I was saying, this URL will probably put that into the description of my session under the conference website. So you can go there and check it there. And as I was saying, those 7 challenges, I highly recommend you to go through all of them. One of the things that I in particular like about those challenges is that they will not really show you, what exactly you need to do. So those challenges, they are not like copy this part here, copy this part there, and then run it, and everything is working fine. Do you understand that? Of course, no. So those challenges are about this is your inputs, this is your task, and this is some documentation website, and this is your favorite search engine. Go and yeah, go and have fun. The idea here is that if you will do that, of course, it will take more efforts from your side to go through all of those challenges. But in addition to that, you will understand much better what you are doing because you will see your own gaps when you will try to basically go through all of them. And I was about basically to show you one of the things related to those challenges. So this is my Visual Studio Code. This is my Jupyter notebook. And the idea here is that if you are, for example, playing the role of the data scientist on a project, then you will usually be working in this kind of an environment. And this is perfectly fine. The issue with that is, can I? The issue with that is if you will try, let me just, if you will try to open this Jupyter notebook in a regular text editor, and I'm doing that right now. Just give me a minute. Uh, you will see that basically underneath. Let me pull it here. So I've opened it in the regular text editor. You will see that underneath the Jupyter notebook is actually a JSON file. Okay, so it's really convenient for the UI to work with that when you have this awesome tool, but unfortunately you cannot run that JSON file, which basically means that when the data scientist created the model, tested that model, and then, for example, committed this file to the source control, now the other person who, I don't know how we can call that person, but because I don't like the term DevOps engineer, let's call him for now uh, just the DevOps. So if the DevOps person will get that, he will be unable to run it. So what he will need to do, he will need to convert it to the Python script. I was converting that Jupyter notebook to the Python script, and as you can see, the Python script looks almost like the Jupyter notebook. Of course, this is a pretty simple notebook, so technically you can do that by just copy and paste, but I was not using that approach. I was using a bit different approach, and let me show you how I did that. I will open this first challenge because this is actually the part of this first challenge. And here, as you can see, you have your objectives. As I was saying, you have some instructions, and you also have here some useful resources. If I'm not mistaken, I need to go here. Let me do that. Okay, and what I can see here, I'm looking for a command that will be probably at the end of the file. Yes, I was looking for this particular command. So if you will install a few packages, you can install them actually from pip itself, which is really, really cool. For example, you install Jupyter, you install and we convert, what you will be able to do, you will be able to run this simple command, and basically you will be able to convert your model from the Jupyter format to the actual Python script. So this is what we can try to do now. I will copy that command. I will go here. I will open, no, you know what? I will actually go here and I will show you my awesome terminal. So I will go to the experimentation folder and I will run this command. I will name this file train2. Okay, because I already have train 1, now it will be train 2. As you can see, it took like maybe a few seconds, maybe even less than a second. And now if I will return here, I have my train 2 Python file. There are a lot of comments. Those comments, they were kind of, inherited during the conversation from the Jupyter notebook to the actual Python script. Of course, if I will do that manually, what I can do, I can manually basically clean up probably almost all of those comments because they are not needed. But the first important part here of this exercise is that in one hand, we are allowing our data scientists to work in the convenient environment, to work in the environment that they are familiar with. And on the other hand, as soon as they checked in the actual Jupyter notebook, we can easily convert that to the regular Python script, and now we can do everything we want with this Python script. So we can run it just with the Python, we can put it inside the Docker container, then we can publish it anywhere. This is, as I was saying, this is the beauty of it. So yeah, this was a very simple example. And yeah, before I will go next, I would like to say a few words. I will share my webcam again. I would like to say a few words again about that. So the idea here is that if you remember, I was saying at the beginning that DevOps it's about the communication. The communication in MLOps it's also important. And when I'm talking about the communication, what I actually mean, I mean that in one hand we, like in the old traditional way of working. We had all the different departments, we have all the different teams, and those teams, they were working in silos, they don't care about each other, and technically, in any case, they will have always the different goals. So for example, if we will take the data science team, the data science team will always have a goal to maintain a decent accuracy score of our model. But if we will take the actual operation team who operate the environment, for them, the goal is to keep the environment uptime, for example, not lower than 4 nines or something like that. So you see that the goals are totally different. And of course, each and every team would like to use their own tools, their own techniques, their own approaches to basically maintain or to reach those goals. And if they reach them, to basically maintain their success level on those metrics. And the idea here is that when you are talking about, again, DevOps, MLOps, whatever, the key part is that never ever one team should force another team to do something in the way that it will be beneficial for one team, but it will have no, let's say, advantages at all for the another. So it's really, really important to find that balance. And an example that I want to again show here is that for the operation team, of course, it will be much more convenient to work with the regular Python files. But for the data science team, if we will force them to create all the code in Python only and not use anything else, well, technically, they can do that, but it will take more time for them to write the code, their performance will suffer, maybe even their morale will suffer. And this is also an important factor because, I don't know, maybe at some point data scientists will just decide that, you know what, I just get sick of that, I will quit and I will go and join another company. And of course, you don't want to do that. So that is why it's always important to find a way how you can keep that balance, how you can allow all the different teams, all the different roles, all the different specialists to work within their own favorite, well-known, well-established environment, and in addition to that, interact with each other. I mean, like, again, this is the thing that I saw on a lot of projects in a lot of teams that they are, for some reason, believe that this is not important, and then they failed just because of that. So not that was not the technology part that was failing, that was the communication part that was failing, or let's say the soft skills part that was failing. I do believe that also all of you are familiar with this phrase, is that employees, they always join the company or they always join the branch, but they will always quit managers or they always leave managers. That basically means that um, the, let's say, the most widespread issue why the people are basically quitting the company, it's because the communication with their managers or peers or something like that. So this is the way how you can avoid that. Okay, now let's actually get back to the terminal and let me share the screen again. I just need to remember that now it's screen number 1, not the screen number 2. So anyway, what I wanted to talk to you next. The next thing that I want to talk to you is how to actually make all that happen. Let me open, I do have that prepared somewhere in another tab. Yeah, probably this. I do have my Azure portal because we are, of course, talking about Azure here. So I do have my Azure portal opened in another tab. Let me just pull it here. So this is my Azure portal. This is the resource group that I've created. And here, as you can see, I have a few resources. I have my Azure Machine Learning Workspace. I have my application insights for logs, metrics, and so on. I have the key vault for the secret, and also I have the storage to store all the data. And then I can go through my machine learning workspace. And here I will be able on the overview tab to click a button, just give it a sec. Yeah, to click a button, launch Studio, and it will launch basically my machine learning studio. And here I can see that I already have a few things. For example, I have the job that I've ran before the session. Under the compute, I have my test VM, I have my test cluster. Under the models, I have nothing, and under the data, I also have nothing. But that's okay. So the thing here is that all of those things that I've created here, technically you can create them manually. Okay. And again, if you're not an infrastructure engineer, you may want to create them manually because the UI itself is really, really good. And even I do believe that this UI is quite self explanatory. But nonetheless, we do understand that if you will create those things manually, it will be really, really hard for you to scale. I mean, like manual things is always easy to start with. You can easily go there, you can easily start getting some first results, but it's really, really hard to scale all of that. Okay, so that is why to scale all of that, to be able to create new workspaces, create new VMs, power up new clusters, publish new pipelines, run those jobs, and so on and so forth, you need to use an automation tools. The idea here is that there are a lot of tools actually that you can use to automate that, but the tool that I will recommend is the Azure CLI. Okay, so the Azure CLI, you can easily install it on your machine. It's a cross-platform tool. It works on Windows, it works on macOS, it works on Linux. I do have actually a few Chromebooks at home, and I will always, like keen about trying to run that on Chromebook as well. Uh, if you don't want to install that tool locally, you can actually run that tool even from within the Docker container. But the tool is really, really simple. So you just type AZ in your command line as soon as you install the tool, of course, and it will show you the help. And as you can see with this tool, there are a lot of sections. I can basically manage almost everything. Yeah, technically not everything, but probably like 90% for sure. 90% of my resources I can manage with this tool. The reason actually why I'm also showing you this tool is because this tool is written on Python and it's open source on a GitHub. So if you know Python, if you want to contribute to this tool, I do believe Microsoft will be more than welcome to see your contribution here. But nonetheless, this tool also supports some extensions. And the thing that is not a part of the initial tool, but rather an extension, is this ML part, which stands for machine learning, of course. So if I will do azml dash ash, stands for help, now I'm kind of going inside that area, and look, I have some commands here, so I can manage my batch deployments, batch endpoints, components, compute, and so on and so forth. For example, I don't know, let's do something like what? Something like compute. Yep, I can, as you can see, create, attach, delete, detach, and so on and so forth. Let's replace compute with the workspace. So basically, my point here is that, oh, sorry, I made a typo. My bad. Yeah, the tool is, and Look how awesome this tool is. It says that workplace is misspelled or not recognized. Maybe I meant workspace. Yes, I did. So let's try it again. Yep, perfect. So the idea here is that I can run that tool and I can create all of the resources that I need. I can create the workspace, I can create the compute, I can publish my jobs, I can publish my pipelines, and so on and so forth. And then what I can do after that, that basically means that if I have those scripts, even though I run them locally, what I can do next, I can now automate and run the same command line scripts from any automation tool. I can run it from, as I was saying, Azure DevOps pipelines. I can run them from GitHub Actions. I can run them from Jenkins. I can run them from GitLab, TeamCity, whatever. So anything technically that can actually uh, sounds a bit of a strange, but anyway, if we're already talking about strange things, technically I can even create that script. And if I don't have any tools that I know or that I like the, as I was saying, like the Jenkins or other, I can even put a regular Linux server and I can create a very simple cron job that will just run the bash script. And on that bash script, I can basically have all the code I need to, I don't know, let's say, do a nightly train of a new model and then publish it. And that will work perfectly. So this is a really important concept here. So you can start with the portal, you can start with the UI, but at some point you will start thinking about how to scale, how to automate. So your next stop should be easy CLI. Let me also do the following. Let me actually open the search engine and just type AZCLI. Look, Azure command line interface. So you go here, and here you will have all of the instructions, how to download it, how to install it. You can install it, as I was saying, Windows, macOS, Linux, run it in Docker, and by the way, you can even run it in Azure Cloud Shell, but this is not really applicable to our case. You will need to use either of those four options: Windows, macOS, Linux, or Docker. I will close those for now. So yeah, now what we can do, let me actually switch back to the camera mode. So what we've established so far, we've established that we have the tool that we can use to basically automate all of the things. So there are a few things that I will cover a bit later. There are a few things that I will cover a bit later, such as how to connect the tool through your GitHub Actions, how to connect the tool through your Azure DevOps pipelines, and so on and so forth. For now, I want to return a bit to one of the topics that we not really missed, because I mean, like, we kind of talked about that. Sorry, not talked, we mentioned that at the beginning, and then I promised you that I will return to that topic later. So probably that will be a good idea to return to that topic now. So the topic that I want to return is how to manage the test data. Okay, that was actually, you may believe that or you may not, depends again on your personal experience, but in my personal experience, working with the automation in general of machine learning projects, the hardest part was basically how we will manage the data. As I was saying at the beginning, when you're creating a model, the model, basically the data, the training data for that model is the essential part of that model. I mean, like, you cannot just ignore that. And the thing is that if you will put the data in, I don't know, let's say some CSV files, maybe some CSV files in your source control together with the code, that may be like a good idea. Yeah, that may look like a good idea, but the thing that you always need to remember, especially when you are doing like that, especially when you're working with the data, is the privacy thing. Okay, so how you can ensure that you will not compromise any privacy. In one hand, let me actually give you an example. So I was working on the project, and on that project, we were also working a lot with the machine learning, with the automation. That was the project for one of the companies in Ukraine. That was a really, really big company. If I'm not mistaken, the total amount of people working at that company was something about like 150,000 people. I will not name the company because I do believe that I can accidentally break the non-disclosure agreement in that case. But nonetheless, the thing is that in that quite a huge company, they wanted to build a machine learning model to basically help their HR department, the human resource department, to keep the employees for working longer at the company. And they want to create a machine learning model that at some point will be able to predict, hey, this person uh, has this probability that he will leave the company. So maybe we need to do something about that. Among the recommendations, we may give him, I don't know, like maybe like a quarter bonus or salary increase or extra 2 weeks of vacation or whatever. Depends on how the model decide which will be the more preferable for that particular person in that particular case. And the idea here is that the HR department itself, of course, they do have access. Sorry, I have an issue with my glasses here. The HR team, they do have access to all of the personal data of the employees, which also includes, for example, their salaries. Okay, their salaries, their vacation balance, and so on and so forth. But the HRs, they were not developers, they were not data scientists, they were unable to create a model by themselves. So that's why they asked us, the engineering team, to do that for them. But if they will give us the random data, and if we will train our model on the random data, then that model will just give like a random prediction. And when we will try to run that model again on the actual data, it may not be as accurate as we saw. Okay, so this is the first problem. But if we will give that data openly, like to the engineering team, then the engineering team will know the salary of, I don't know, maybe not all of the company employees, but at least to some part of the company employees, which of course will compromise the privacy because, and again, I mean, like the security part of it is also really, really important because it may be that some other company, a competitor, would like to pay a data science engineer because he has access to the data, so he will basically share the data outside the company. So now we have like a huge security violation. So the thing here was about how to impersonate that data. And to impersonate the data, we were running basically a few interesting algorithms how to hide the data. I'm not really actually, I will not be able probably to explain all of those algorithms because again, I do have a mathematical degree, but I was not really involved in that part of the implementation, so I cannot say exactly how we manage that. But I just wanted to explain that case to you so you will know that this is actually a problem. Of course, when you're working with the open data, it's not a problem at all, but believe me, not all the data that you will be using to train your models, not all the data is so open as as you may think. So that was actually my biggest problem. How we manage that? as I was saying, we were just having a dedicated tool, a dedicated exporting engine, and that engine, it was basically pulling the data without our involvement. It was pulling the data from the original system, from the original HR system, and then it runs some impersonation algorithms, sorry, not impersonation, the obfuscation algorithms, and after that, that data was sent to the engineers, and the engineers were unable to decipher. The engineers were still able to see that, for example, employee number one has either a bigger or lower salary than the employer number two. So they saw only the, for example, the relative difference in those things. The same as with the vacation budget, that the employee number five has more vacation days than employee number 10, and so on and so forth. But they never saw the original values, and that was actually my biggest challenge. I'm not sure that I have any recommendations how to address that challenge in particular, because I do believe that in any case it depends on whether your model, for example, requires to have the relative data or requires to have the absolute data. But yeah, this is basically the big pain point, and I should probably stop talking about that and switch to something else. So on that, let's actually switch to something else. Let me show you. Let's assume that you already have your scripts created with AZCLI, and let me show you basically what you can do next with those scripts, how to run them, for example, in your GitHub actions. I will put my glasses back on. I will share my screen. Okay, so I hope that you can see my screen again. So I was talking about how you can actually run, for example, those command lines, how you can run them with your GitHub actions. So if we're talking about GitHub Actions, and I will again refer to this sample code here. If we're talking about GitHub Actions, the good thing is that each and every automation on GitHub, on Azure DevOps, and probably on every other tool of the same sort is just a file. Now, the kind of the standard is that it's a YAML file, but I do remember that in some cases, I saw that some tools are using JSON format or something like that. But nonetheless, it's, as I was saying, in most cases it's YAML. So let's open this simple file here. So this is the actual pipeline. It's not the entire pipeline; it's just a part of pipeline. But nonetheless, let's just try to take a look what we have here in this file. Okay, so this is how your average pipeline will begin. You can define things like what will be the name of that pipeline. You can say that it will be triggered on workflow dispatch, which basically means that in this case it will be triggered only when you will go manually and click a button on a GitHub that I want this pipeline to run. But additionally, you can specify here that, for example, when the new changes appeared on the master branch or maybe some other branch, then you will trigger that pipeline. Again, now you're saying that you will have some jobs, and the first job you name it train. This identifier should be unique. You're saying that you will run that on the latest image of Ubuntu, which is actually not the good practice, but I will again come to that a bit later. And then you're saying that I will check out this repo, and here you're using the built-in action, a built-in action of the GitHub Actions. But here, Look, you are using a general run statement. You are running a general command line script. Az extension add dash name ml dash y. What it actually means, it's a really easy to understand. I will show again my favorite tool to you. Let me clear this out. It's really easy to understand because this is how you can understand that. You're just typing az extension add dash ash. So this is the command that will install the extension for the az CLI tool. In this case, the extension is the ML extension I was talking about. So you will install that extension. As soon as you will do that, you will be able to create those scripts to create the workspace, to create the compute cluster to train your models, and so on and so forth. And then yet another built-in action is Azure login. As soon as you will do that, you can do some other scripts here, which can be something like, let me just go here and go to the second challenge, just to show you how those scripts may look like. If I'm not mistaken, we need to go here to the first link again. Yeah. Create Azure Machine Learning resources with the CLI. A learning model on Microsoft Learn. And here, for example, this one, I was checking them to make sure that everything is working fine. And see, you have here Azure Resource Group create, Azure configure, set the default resource group name. Then you have Azure Machine Learning Workspace create, and so on and so forth. So those are your commands that you're running with AZCLI. With those commands, you can achieve a few things. So first of all, with those commands, you can avoid keeping your resources running 24/7. With those commands, you can run the resource, you can run, for example, your cluster only when you need it. You can easily provision, deprovision those resources, and so on and so forth. And second, it also helps you to trigger the actual pipeline. I am not remembering exactly in which module that was here, but let me try to find that really fast. No. Okay, maybe it was not here. Maybe it was in some other place. Probably here. Create an environment. No, that's... No. Okay, I will not look for that anymore. I was about to show you basically the commands that you can use to publish your to create your pipelines, to trigger your pipelines, and so on and so forth. But maybe it will be easier if we will just do it here. Yeah. For example, you have jobs here, so you can do azml job -s -help. And you can see you can create the job, you can list all of your jobs, you can update your jobs. So this is basically how you will do that. This is basically how you will be managing your jobs. I do believe that there was an example in the document, but as I was saying, I cannot find that example, so that's why I will not look for that anymore. In any case, so let's get back to this guy here. So here you will have something like, for example, azml job create, and then maybe some extra parameters. So this is a really easy way to do that. And why it's so easy? Because when you're creating this pipeline, those commands that you're running from here, you can easily run the same command from your local machine. So I can, for example, copy this command over here. I can go back again to my terminal, and I can run this command here. And look, it shows me that the extension ML is already installed, and yeah, basically everything's working fine. So in that case, I'm sure that if on the target machine there is no ML extension, then I will install it with this command. If there is already one installed, then it's fine. Still, it will just skip it and proceed with the next step in my pipeline, which is Azure login. Okay. So another thing that I want to talk a bit about is why this Ubuntu latest here is bad. Before I will do that, let me actually do one more thing here. Let me go to Microsoft Azure Machine Learning Studio and also show you that under the environments, you also have a lot of built-in environments. Those are basically the predefined configurations which you can use to run your algorithms, to train your models, and so on and so forth. And here, look, you see Microsoft always explicitly specifying what is the version of each and every environment. Why? Because it's a very important thing. You know that in, let's say, one version of a library, you may have some functions, some methods that are behaving in one way, but with the update, they either can be deprecated or now they can behave differently. Maybe to some extent they maybe have better, maybe to some extent they maybe have behave not as you expect. In any case, if you will put latest here, you have no control at all over which exact version of the Ubuntu you will be using here. I faced that a few times myself when on Friday, for example, your pipelines were running fine. Then on the weekends, you had a conference, and on that conference, a new version of a tool was revealed. And then basically on Monday, the tool was updated. So now the latest version, for example, with the Ubuntu, some time ago, the latest version was 2004, but now the latest version is 2204. But maybe you had something that expects you to run explicitly on Ubuntu 2004. And if you're using latest, you have no control. At some point, your image will be updated. And as I was saying, on Friday, your pipelines were running fine. And then on Monday, your pipelines stopped working. So you are trying to create the same build. You are trying to produce the same results that you tried, like a few days back. You are using even explicitly the same commit in your source control, but it's not working. And one of the reasons why it may not be working is if you're using latest versions here. So this is another important recommendation from my side. Try to avoid using the latest version. Always try to specify the the explicit version. So is it, I don't know, is it for the image of your build agent? Is it for the version of the built-in environment that you are using? In all of those cases, as I was saying, always specify what will be the actual version of that resource. It's really important. Okay, The only thing that we didn't talk about when we're talking about this part is what this actually means. So when we're talking about how we will authenticate in Azure, we have a few ways how to do that. And here we are authenticating with the service principal. And the idea of authenticating with the service principal is that we have an identity which looks almost like the user identity, but it's not. It's more like the system identity that is used to service or system to system authentication. And again, if we will go probably, let me just close all of that, that we don't need. So this is the challenge number two. Why number two? Because we started with the 0. And if we will go here, if I'm not mistaken, again to the first link of our useful resources, we will have that code snippet that we will need to use. So I don't remember exactly where it was, but it was somewhere here. Or maybe not here. No, not here. Wait a sec. Okay, let me just try to show to you like this. AZCLI login. So there are a few ways how you can sign in. You can just type the command az login, and in that case, it will ask you for your login and password. But you do understand that when you're working with the automation, that is, of course, not the case, because in that case, your automation will just stop. Sorry, and your automation will just stop, and then it will stay there forever, waiting for someone to enter the password. You can do like this, login and password, but as you can see, first of all, it doesn't work with Microsoft accounts that has two-factor authentication enabled, and the second is that this is actually an extremely unsecure way of doing that, because you can easily, by mistake, expose this password. And if your password here is exposed, then it's exposed. But with the service principal, this is how you can authenticate. So the command is az login service principal and a few arguments here. To be able to log in as a service principal, what you will need to do, you will need to create that service principal. As I was saying, service principal is basically a service identity that is used to do the service to service authentication. And if I'm not mistaken, to do that, you need to start with AZSP, stands for service principal. Let's try that. Or maybe it's AZ Active Directory SP. Yes, sorry. It's Azure Active Directory Service Principal. Yep. See, what you can do here, you can create it here, or you can create it for role-based access control. What I will recommend you to check the documentation for both of those commands. But I mean, like just to understand a bit better what you're creating here. But the thing that you will need to run, create for role-based access control. Create for role-based access control. Yep. As you can see, there are a bunch of arguments that you will need to run, that you will need to provide to create that. But again, the thing is that on your team, you will have someone who know how the data science works, and you will have another person who will know how the infrastructure and security works. And with this part, You will need to ask that person, the expert in security and infrastructure. He will help you with that. As soon as you will have those credentials created, what you need to do next, let's try to do that here. You will need to go to the GitHub. I've already logged in with my account, and let's go to this organization. This is the humanitarian app that we were working on with the team. You can go to settings, and under the settings on the GitHub, you have secrets. And here you have secrets for actions, code spaces, and so on and so forth. You need to go secrets for actions. And here, look, you can put as many secrets as you want, and basically all of them, they are just the plain text secrets. So those are just, let's say, passwords. You can create new secret, something like my secret. Something like this. As soon as you will edit, no one will be able to see it. It's locked. Okay, you can edit it, so you can override it with some new value, but you can never ever read it. Okay, it's asking me for authentication code. I don't want to do that because I was, basically creating that for the demo purposes. Okay, even to delete that, I need to do the two-factor authentication. So yeah, I will basically do that later. And then what you will have, I will again show it on the example of this application. One on a GitHub, you will go to actions on a on your GitHub repo. You will go to actions. Here on the left side, you will see that, for example, you have one workflow. In my case, it's called humanitarian European web app, and you will see the history of all the runs, which of them were green, which of them were red. You can go inside. You can see what were the steps, and so on and so forth. And as I was saying, it's a really, really, really simple way to just create basically your command line scripts and run them as a part of your GitHub actions. With the Azure DevOps, it's working in a similar way. The only one difference is that when you are doing that with the Azure DevOps, you need to create a thing called the service connection. You can still manage the secrets in the same way as I showed you with the Azure, with the GitHub, but with the Azure DevOps, they are still more leaning toward the way of managing the service connections. Let me actually try to show at least a bit on how it works with the service connection. So I have my demo instance of Azure DevOps here, and I'm doing a lot of things there. Let's choose this project. And if I will go to project settings, here I have service connections. And look, in this case, I'm having a service connection through the Docker registry and the service connection through my Azure subscription. You can create a new one. You choose the type, and as you can see, there are a lot of different types of those. You can start with Azure, choose an Azure Resource Manager, next, and then you can choose, for example, Service Principal Automatic. If you will do that, then that service principal that for the GitHub you will need to create using the AZADSP create for airbag command. With the Azure DevOps, the service principal will be created automatically for you, which is really, really cool. And then you will just refer basically that service connection in your pipeline. But the pipeline itself is basically the YAML file. Okay, On that one, I will share my webcam again, and I would like to talk a bit about probably uh, the final point of this workshop is that we understand what we can do to get started basically with building our model, collaborating on our model, training our model, and potentially publishing our model. But a a crucial point that is kind of, expected to be in both cases when you're creating a regular app and also when you are creating your machine learning model, is that as soon as you deploy that on production, now you need to give the access to that app to your end users, and now you need to monitor what they are doing. You need to learn from their experience. You need to ask for their feedback about that and use all of those inputs to improve basically your application, your model, or whatever. And again, if with the application it's still expected, but it's not truly a common practice to do, unfortunately, with the machine learning model, I do believe that this is the essential part of it. So the essential part of it is that uh, at some point you will need to rebuild your model. On that one, let's actually think about true reasons why we may want to rebuild our model in the first place, why we may want to create a new version of our model in the first place. So the first reason is, let's say, relatively obvious, is that, for example, we um, we may want to create some new code, change something in code, which will mean that now we want to build a new version of our model, and this new version of our model needs to be, again, trained, validated, and published. But the second reason maybe is that when we were running our model, we get some new data, and we want, for example, to keep the code the same, but now we want to use the new data, train the model again, and to train the model, we're using the new data, and therefore we will train the same model, the same code, but on a different data source. Of course, we will have the different model at the end. So that basically means that that can be a second reason for us to do that. Let's talk a bit more about those reasons. So when we are talking about the first thing, which is obvious, is that when we're changing the code, we want to rebuild and la la la. This is super simple and straightforward. When I was showing you the GitHub Actions, and I was also saying that that example that I was showing you, it needs to be triggered manually based on the workflow dispatch trigger, but you can also do that automatically. You can say that each and every time I have a new changes in my main branch, let's rebuild that. The second part is, what if the data changed? Okay, so the code remains the same, but the data changed. In that case, for example, if you're using the Azure Machine Learning Workspaces, you have a dedicated section for your test data. So the test data, it can use a lot of different data sources. For now, in my example that I will show you in a few moments, I'm using the Azure Blob Storage, and with Azure Blob Storage, what I can do as soon as the new data arrived from, I don't know, like anywhere, I don't really care. I will upload that new data to my blob storage, and because everything else remains the same, I'm just triggering the rebuild of that model. This is a very, very important part. By the way, maybe I missed that during my explanation, but this is a good opportunity to highlight that right now. Is that when I'm talking about using Azure Machine Learning Workspaces and automating that with GitHub Actions or Azure DevOps, what I'm saying is that in both cases, our automation will not execute any code on the automation side of it. I mean, like when we're creating our GitHub action, the GitHub action itself will not run any Python code at all. It's not needed. The GitHub action, what it will do, it will only send the commands to the Azure workspace, and the Azure workspace, the Azure Machine Learning workspace, will run all the things for us. Why this is important? Why this is important? Because usually when we're talking about, let's say, the general build tools like the GitHub, like the Azure DevOps, like the managed instances of GitLab, Bitbucket, and so on and so forth, usually they are providing you only with the machines that has some CPU and RAM, and that's it. But the thing that I mentioned probably at the beginning of my session here is that uh, when you're working with the machine learning, of course, in some cases, you may want to use the GPU-powered virtual machines. When you're working with managed services, it's not always so easy to get your build agent running on a GPU-powered virtual machine. When you're using the Azure Machine Learning Studio, Azure Machine Learning Workspace, sorry, you can easily achieve that. You can create your cluster on a GPU-powered machine, and then you're using a very, very simple machine underneath the GitHub Actions just to automate that, just to send the commands. Please do this, please do that. So yeah, on that one, what I wanted to show, I just wanted to show how that works. So let me share my screen again. Screen one, allow, and I hope that you can see my screen. So I'm again on Azure portal. I have my resource group, and again, I'm using the storage account here. That storage account was created as a part of the creation of the machine learning workspace in the first place, and I'm using the exact storage account to manage my test data. If I will go to containers here, you will see a lot of things here, all those things that are needed for the machine learning workspace to work in the first place. I did here one thing that is not really according to the best practices, but nonetheless, I've created a container here called the test data. But I will always recommend to create a new storage account, a dedicated storage account for your test data. So the reason why I will recommend that is because, first of all, you don't need to be afraid of billing at all, because Microsoft will always bill you not by the amount of the storage accounts or containers that you've created. It will always bill you by the amount of the actual data that you stored there, which basically means that storing 1 TB in one container will cost in one storage account will cost you the same as storing, for example, 100 GB in 10 different accounts, 100 GB in each of those accounts. But anyway, I have the test data container here, and I do have a file, the diabetes dev CSV file. And then in my studio, under the data, I have data stores. And here I've connected this custom data store called test dataset. And as you can see, it has only this one file. I can browse it, and I can see basically what the data is look like in that file. The idea here is that, again, because it's just a file here, what I can do, let me open a terminal, and I don't really remember the command, but I did a typo. But I will basically find that command really, really fast. So it's something like Azure Storage, probably blob, boom, upload. Yeah, upload batch. Yeah. This is the command I was looking for. Azure Storage Blob Upload Batch. So this is the command that you can run from the CLI. It can upload a bunch of files for you. So that basically means that when you are collecting the data, when you are learning from the usage of that model on production, you just need to store that data somewhere. You may even actually directly store that data to the same storage account. But if you don't, you can store them somewhere else, and then you can export them and import them really, really easily through your storage account. And the data was changed, so the only thing that you will need to do here, you will just need to trigger the same pipeline that was used to build your model initially. Okay, and as soon as you're done with that, you're ready to go with the new version of your model. And this is how it works. I do believe that this is all that I want to share with you for now. So I showed you where to get started. As I was saying, this link is basically your entry point into the MLOps. Achieving like all those finishing all those challenges may take you, as I was saying, a few days. Each of those challenges is probably, again, Microsoft usually specified it as something like 30 minutes to 45 minutes, but again, it depends on your actual experience with Python, with machine learning, with Azure, with build automation, and so on and so forth. I will probably say that if you are relatively new to all of those areas, then it will probably take, I don't know, like 3 to 4 hours for each and every challenge. But it definitely worth it. I mean, like it's a really, really good challenges, and I really recommend you to go through them. On that one, I'm done. It took what almost 2 hours for me to talk about all of the things. I'm sorry that I was unable to show a lot during the actual demo sessions. Again, it's all thanks to our neighbors who are trying to invade our country right now, but we're not allowing them. And yeah, if you have any questions, I do believe that that can be a good opportunity for you to ask those questions in a chat. I will be happy to answer those questions. If you don't, then what? Then I will probably meet you either on my second session during this conference. That will be a different session that I will run on 6th of December. And why it will be different? Because on that session I will be showing how you can use the built-in services to create something on top of them. I will be showing how you can use the built-in services for the face API, for face recognition API. And the idea there is that now you are not directly, let's say, creating your own ML models. Now it's more about that the general ML model is created and updated for you, and you are just consuming it as a developer. It's a really, really cool and interesting concept. So I encourage you to join my session. I also encourage you, of course, to join all the other sessions. But nonetheless, let's get back to my original question. So, do we have anything that we want to discuss with you guys right now? Any questions, comments, ideas that you want to discuss with me today? Okay, I'm monitoring chat and it looks like a no. I know that we do have a lot of attendees from Ukraine, and I also know that the quality of the internet connection in Ukraine, due to the same reasons as I've already mentioned a few times, is not the best. But anyway, guys, so you probably, I mean, Like, because you're here, you probably know where the conference website is. I do believe that in my profile, I had a link to my LinkedIn, uh, maybe also to my Facebook or Twitter. I don't know, but feel free to use all of those social platforms to send me a message if you want to talk about Azure or something cloud related. I will be happy to maintain the conversation. And on that one, I wish you the good rest of the day. I wish you the good conference. Stay safe. Uh, when should be the next session? You said so. The next session, my session, will be on December 6th, because on December 6th we're having the full day of the conference. Let me just, you know what? Let me just open a schedule so we can go through that schedule. So it's transformdevrain.com. Then you click on a schedule. Uh, we have the workshops that are running from yesterday basically and till the end of this week. So today was my workshop. Tomorrow that will be the workshop from Stas, and then also two more workshops by Adam and Alexander, who is also on a call with us. Yeah, and Alexander is sharing in a chat the same link that I'm showing right now. And the conference day will be on December 6th, and we will have a lot of cool sessions there. One of them will be my own session somewhere here, probably. Yeah, here it is at the end of the day. So yeah, feel free to join us on all the other workshops. Feel free to join us on the conference. I will be super happy to talk to you again. And yeah, feel free to invite your friends, colleagues also to join us on those events. As you can see, we're trying our best to keep the things running. Cool. By the way, I just realized that we have the awesome functionality of a chat. So, despite I promised that we will put that link into the conference on the conference website, I will also put that link here in the chat, the link for the MLOps challenges that I was yeah that I was advertising so hard during my session today.